last topic in this section is going to be even and odd functions. The good news is this is something you already know how to do. We just need to learn what the word even means and what the word odd means, okay? Even and odd has to do with symmetry, and we learned symmetry back in section 2.1. Okay, so let's read about even here. It says a function is even if it has blank symmetry. Okay, what you need to commit to memory right now is that an even function has y-axis symmetry. Okay, so even means y-axis symmetry. Okay, so think back to section 2.1. Remember the algebraic test for y-axis symmetry. This means that whenever the point xy is on the graph of f, then the point negative xy is also on the graph. Okay, remember when you tested an equation for y-axis symmetry, y stayed put and you changed the sign of x. Okay, and then once you made that replacement, you simplified the equation and then you looked back to see if it matched the original equation. Okay, if you got the original equation back, then the graph of the equation had y-axis symmetry. If you did not get the original equation back, then the graph of the original equation did not have y-axis symmetry. Okay, so it's the same thing all over again, but now you're calling a function that has y-axis symmetry an even function. Okay, so odd, what does that mean? A function is odd if it has origin symmetry. Okay, this is easy to remember. O is for odd and O is for origin. Okay, so you've got to think back to section 2.1 and remember the algebraic test for origin symmetry. So if xy is a point on the graph of f, that means that the point negative x negative y is also on the graph of f. Okay, so the algebraic test for origin symmetry, you would take your equation, you would replace x with negative x, y with negative y, simplify, see if you got the original equation back. Okay, if you do, the graph is going to have origin symmetry. If you don't get the original equation back, then the graph is not going to have origin symmetry. Okay, so right now, you've got to put in your brain, even is equivalent to y-axis symmetry, odd is equivalent to origin symmetry. Okay, so your next question is probably, well, what about x-axis symmetry? There's no fancy name. Okay, and that's true. Okay, I'm going to talk about that for a second. Okay, there's an example down here, but I do want to talk about why there is no fancy name for x-axis symmetry. So I'm going to write, what about x-axis symmetry? Okay, well, let's think about this. So I am going to draw something. I'm just going to draw something random that has x-axis symmetry. So let me put the axes here. Okay, so here we go. Here are my axes, and then I'm going to draw in a curve. I'll put it in blue. Well, let me put it in green. Let's say we have a sideways parabola. Okay, so this graph has x-axis symmetry. Okay, if you folded the sheet of paper along the x-axis, then this portion, the top portion of the graph, would lie on top of the bottom portion of the graph. Okay, so this graph has x-axis symmetry. Okay, now what I need you to realize here, okay, if you go back to the title here, we're talking about even and odd functions. Okay, we are classifying functions in terms of their symmetry. Okay, well, what happens if an equation has x-axis symmetry? What is true about its graph? Well, it fails the vertical line test. Okay, so anything with x-axis symmetry fails the vertical line test. So it's not a function. So since it's not a function, it doesn't fall into this classification of functions in terms of their symmetry. Okay. Going like when we were in section 2.1, we were working with equations that were both functions, and we also dealt with some equations that were not functions. Okay. So now going forward from 3.1 on, since we know what a function is, we are only talking about functions. Okay. So you are going to be asked to classify functions as even or odd. Any function that you encounter will not have x-axis symmetry, okay? Because if something has x-axis symmetry, then it'll fail the vertical line test. It won't be a function, okay? So any function is not going to have x-axis symmetry. That is why there is no special name for it, okay? All right, so let's do an example here. Okay, this is a quick example. We're going to go down to example 6 where we have 3 different graphs. And there's no equation, so you're not doing any kind of algebraic testing. You're just determining even or odd from the graph. Okay, so again, this is all related back to symmetry. Okay, so the directions say, state whether each function is even, odd, or neither. Okay, first of all, you need to realize that each of these graphs represents a function. Each of these graphs passes the vertical line test. So we're dealing with functions, so they can either be classified as even, odd, and it is possible for your graph to have no symmetry, and in that case, the graph will be classified as neither an even function nor an odd function. Okay? All right, so again, this is the same thing from section 2.1. Now we're just attaching the fancy words even and odd. Okay. All right, let's look at this graph on the left. Okay, so first of all, let's think about this. If it were even, okay, so the graph is what you see in blue. If it were even, if you folded your sheet of paper along the y-axis, then the left side of the graph would lie on top of the right side of the graph. Okay, so this piece right here, you can see where my cursor is. If you folded it over on the y-axis, this blue piece would show up over here. Okay, that's not perfect, but you get the idea. The blue piece would show up over here, and that's not what you have. Okay, so this graph does not have y-axis symmetry. Okay, so it's not even. Okay, odd. Okay, so remember how we determined odd origin symmetry? That is a little tougher to visualize. So what we did in 2.1 was we picked a point. Okay, so 1, 3 is on the curve here. Okay, and so then the rule for origin, if you pick a point, then if you change the sign of both coordinates, that point should also be on the curve. So that means -1, -3 should also be on the curve. Okay, and it's not. Okay, so this particular graph is not odd. It does not have origin symmetry. Okay, so this particular function is neither even nor odd. Okay. All right, the next graph, the one in the middle, okay, let's first check for even, okay? So again, you know what I just did with the points? You can do the same kind of thing for y-axis symmetry, especially if you have trouble visualizing the flip. You can pick a point on the curve. I don't know, that's kind of tough here because well, this point looks like it's falling exactly on the grid line. Okay, so this point is 2, 2. Okay, so if you're dealing with something with y-axis symmetry, y would stay put and you would change the sign of the x coordinate. Okay, so we're asking ourselves, is the point -2, 2 on the graph? And yes, it is. Okay, so what's going to happen, that's just one specific point, but if you did fold your sheet of paper along the y-axis, this right side would lie on top of the left side. Okay, so this graph does have y-axis symmetry, so it is even. Okay, so something I haven't brought up yet, if you're dealing with a function, it cannot be both even and odd. Okay, back in 2.1, we were dealing with the equations, some of them that were not functions. And if you're dealing with something that is not a function, it is possible for more than one type of symmetry. Okay, but if you have restricted yourself to looking at functions, a function can be either even or odd. It can't be both. Okay, it can be neither. So it's either one or the other or neither. Cannot be both. So since we know this function is even, it cannot be odd. Okay, it can't have origin symmetry. And that's clear. We know 2, 2 is on the graph. So if this graph did have origin symmetry, -2, -2 should be on the graph, and it's not. Okay, so this graph is even, not odd, and we can't write down neither because it is even. Okay, all right, lastly, okay, this last graph, it kind of looks like x cubed. So it's not, but it looks like it. Let's check it out in regards to symmetry here. Okay, let's first think about y-axis symmetry. Okay, so I'm going to pick a point here. Okay, this is 1, 3. Okay, so if this graph were symmetric about the y-axis, that means that I would keep the y value the same and I change the value of the x coordinate. Okay, so -1, 3 should also be on the curve, and it's not. Okay, so this graph does not have y-axis symmetry. Okay, and then let's talk about odd. Okay, so origin symmetry, that means that if you pick a point to test it for origin symmetry, you're going to change the sign of both coordinates. Okay, so we're going to take a look at -1, -3, and that point is on the graph. Okay, so this graph does have origin symmetry. Okay, again, it's odd, so it can't be even. Okay, and we're going to scratch out neither because it is odd.